up the vibrations through the fluid. So when I make contact here, as I rub it over different surfaces, you'll see different patterns of high frequency vibration. If I run it over the microphone, you'll see the ridges of the microphone being picked up by the vibration sensing modality. And we're in the process, which by the way is greatly enhanced by a pattern of fingerprints that are embossed into the skin, which was a great surprise to us all. It turns out fingerprints are there not just for the benefit of the FBI. They actually make your vibration and texture sense about 30 times greater than it would otherwise be, and it does that for our finger as well. The last thing you do is you can look at something and decide whether it's metal or plastic when you touch it by feeling, of course, that metal is cold and plastic would feel warm. Well, of course, they're all at the same ambient temperature, so how is that? It's because your finger is warmer than the things you touch, and you're detecting the heat flux, the rate at which heat leaves your finger as an indication of the materials. We're doing the same thing. There's a thermistor, and the record here is the DC temperature, which is actually of value to our sensor for calibration purposes in different ambient temperatures. But what you see on the bottom there is the AC response, which are cooling profiles. And from the same cooling profiles, we can extract what the properties of the material are. Of course, you can only do that if you apply force in a known place with a known amount of force. And so having all the sensing modalities co-localized, so we can determine the force as well as the slip and as well as and calibrate then our temperature and vibration sensing.